the brushless DC motor, the AC servo motor, it's the same words, describing the same machine. Some of the characteristics. One fundamental characteristic of a servo motor is that it has a permanent magnet rotor. Okay, so I've got a couple of rotors here on the table, so again you kind of see the evolution, you see the armature, you see the induction motor, and the servo motor has permanent magnets on the rotor. These are kind of taped up, so unless you kind of get a side view of it, you might not just see, oh, those are permanent magnets. I've got a small one here, it's a little bit easier to see the actual magnet. That's just a magnet glued onto a rotor, and that's it. And you can kind of get an idea for the magnetic poles. I've got a magnetic pole tester. This has a Hall effect sensor in it. I'll explain what a Hall effect sensor is, I guess, as we go, if anybody's interested. But this will just show you the magnetic pole is north-south, north-south, north-south on all of these. So I can look at the magnetic pole, I can move it around, and it's just going north to south. So they just lined up these magnets and go north and south.
What do you use that tester for?
Well, here in the servo lab, that's one of the things that really will kill or condemn a servo motor from repairing it. From the repair standpoint, is if this magnetic rotor flies apart. If that magnetic rotor flies apart, boy, I mean, this seems pretty simple. If you can see, well, Greg, if it flies apart, just glue a new one on there. Okay, maybe, on that simple one, maybe I could glue a new one on there. But they get pretty complicated. And they'll get complicated to the point where you can understand why in the servo motor shop I wouldn't want to mess with it. This is one that flew apart. And these are the magnets that it's made up of.